Hello everybody. In this video we are going to be looking at primitive types in Python. So majorly in Python you can classify data types to primitive and non-primitive types. In this video we'll be looking at the primitive types. So we'll be looking at the primitive types. So for primitive types we have numbers, we have strings, and we have booleans. So let's look at this in action. So for numbers, first of all, we have ints, we have integers, or you can call them ints. So we have integers. So let's look at integers. Let me set the variable. Let me set it to 50, for example. So this is an integer. Let's print x. So print x, we have 50. So this can be any number, any whole number. So even if you do something like this, okay, so you can look at the type. Look at the type now, you see an integer. Any whole number at all. It could also be negative. Negative whole number is also an integer. You can see this. So let's look at floats. We are still under numbers. Let's look at floats, or you can call them floating point numbers. So for floats, we have, let's say for example, 9.81. Let's print y. So look at this, 9.81, beautiful. So let's look at the type of y. Okay, sorry, I didn't close this. So let's look at the type of y. We have float. It belongs to a class float. So any decimal number at all is a float or a floating point number. So any decimal, it could also be negative. Look at this, we have float. What are other type of floating point numbers we can get? You can also have something like this. Look at this, we can have 1 exponential 3. Let's print this. So okay, so I'm still printing type. Let me print it itself. So let me print z. Look at this, 1000. What does this mean? This means 1 times 10 raised to power 3. That's what this exponential means. It means 1 times 10, then this 3 is the power that you are raising it to. So basically 1e3 is 1 times 10 raised to power 3. It could also be negative. For example, you can have something like this. You can have 2.5. You can have e raised to power 4. It can be negative, or it can be. So let's look at this first of all. So let's print a. Look at this. So we have minus 2500. It can also be something like this, for example. So basically, this is telling us that 2.5 times 10 raised to power minus 4. That's what it means. You could also use a capital letter E or a uppercase E. So it can be uppercase E and we still get the same result. So exponential can use a uppercase E or a lowercase e for exponential. So let's look at another thing that we have. We're still under numbers. We have complex numbers. You can call it complex if you like. So we've not used A so far. Okay, we've used A. So let's look at B as our variable. Let's look at something like 3 plus 4j. So you all know about complex numbers, and if you don't know about it, you can look it up. So this is a complex number. You can see this 3 plus 4j. We can check the real part and the imaginary part. So complex numbers contains, or it comprises of a real number and imaginary number. So this is the real number, this is the imaginary number, where j stands for the imaginary part. So let's look at this. So beautiful, b dot real, the real part is 3.0. And we can look at the imaginary part is 4.0. And we can look at the type of b. Look at the type. You see that it belongs to a class complex. So that is it on numbers. We also have strings. We have strings. So strings are like textual data. So we can have something like this. We can call it Smith. Let's print name. See what we have. So we have Smith. Beautiful. We can look at the type. We can look at the type. Look at this. It belongs to a class str. So it belongs to a class string. What other types of string can we have? We can have something like this. Let me call it greet. And see, and it can also be a single quote. So it can be a word like this, or a phrase, whatever you want to call it. So you can print greet. So look at this. We have str. It still belongs to a type string. So it can be anything. It can be anything, a full sentence, whatever. So strings are like a textual data. So what separates strings from numbers is that you have to wrap them up in a quote. You can also have something like this. For example, let's say 172. This is an integer. Good. But if you had something like this, like some text to it, so it becomes a string. So you can give it, you can call it height. So you can call it 1 print. Then I can wrap it up with a quote. So if you look at the type of height, see that this is also a string. This is beautiful. So now we have booleans, which are true or false values, or you can call it true or false values. So we have booleans. So we can say something like a spade. Can set it to true or false. So if you print a spade, so I'm printing on the same line. So if you print a spade, you can print this. Let's look at what we have. So this is true. And this, we use this to make decisions in our code. It can also be false. Like this. Look at this, false. Okay, so and I started with an uppercase and then I used lowercase after. So you start with an uppercase. If you do something like this, it won't work. Or you do something like lowercase all through, it doesn't work. So you write it like this. So and then you do like this, and you can look at the type. Let's look at the type. So it belongs to a class bool. So this is the basics of primitive types. So let me break this down for you. So we have numbers, which are whole numbers. It can be negative or positive. We have floating point numbers, which are decimal numbers, and we can have something like this, exponential. It also belongs to a class float. And then we can have complex numbers. And we can also have strings, which are textual data. And we have booleans, which can be either true or false.